Okay, I hope everybody's having a great Friday. I know you are excited to learn about the Lewis concept of acids and bases because obviously we can't take a day off. So anyways, we've already talked about the Bronsted-Lowry definition, an acid being a proton donor and a base being a proton acceptor. The Lewis concept's a little bit different. A Lewis acid is an electron acceptor, where a Bronsted acid donated an electron. You can remember that because acid acceptor for Lewis. A Lewis acid is an electron pair acceptor, meaning it can take in an extra pair of electrons. A Lewis base can donate an extra pair of electrons. It's an electron pair donor. The great thing about Lewis acids and bases is that it allows us to cover many more things that do not fit the definition of a Bronsted-Lowry acid and base, but still have acidic and basic properties. They often don't even involve a proton transfer. We'll have some examples of that. We talked about these guys earlier, the metals when they get surrounded by water. There's actually no protons being transferred here. What's happening is aluminum is accepting two of the unshared electrons, one of the electron pairs around the oxygen in the bent water molecule. Same thing's happening here. Boron is accepting an electron pair from nitrogen. Water and NH3, ammonia, act very often as Lewis acids and Lewis bases. And we can see that here. We have this picture from our book we're going to look at that show why. Water has got this great amount of electrons up here to be able to donate. Ammonia has a pair of electrons that it's able to donate. So, as we go back to our notes, again, bear with us as this is the first time we're trying this. We're going to look at this example of how water bonds to a proton through the Lewis acid-base idea of being an electron pair acceptor and an electron pair donor. Why the H plus is going to act as the acid and accept a pair of electrons, where the water is going to act as the base and donate a pair of electrons. So we'll take a look at that here. What happens in the water molecule is you end up with that bent shape you learned about way back when in chemistry. You have that oxygen with his two sets of unshared electrons forcing these bonds down. Bond angles and all that we'll get into later in the year. Right now we're just focusing on the idea that there are two pairs of unshared electrons that can be donated. When a hydrogen comes into the picture, a proton, an H+, how a hydronium gets made is that oxygen actually says, oh, I feel really bad for you, hydronium ion. I want you to have at least a couple of electrons, and decides he's going to go ahead and share those with this hydrogen. So you end up with a new looking molecule where oxygen just has one pair of lone pairs and it's bonded to three hydrogens. These two bonds already existed. This bond right here, those are those two electrons that are now being shared with hydrogen. This whole entire compound or molecule or ion has a positive charge. That's what we've been talking about in class as being, up to this point, H3O.